Welcome to Study Loop.
Hi, here in this given problem, power of the nichrome heating coil that is given as P is equal to 500 watt. The voltage applied across it, that is 110 volt, and its diameter, that is 0.500 millimeter. So its radius of cross section, that will be half of the diameter, means 0.250 millimeter. Now in the first part of the problem, we have to find length of the nichrome wire, for which the resistivity of the nichrome is noted to be equal to 1.00 into 10 raised to the power minus 6 ohm into meter. So using an expression for the power as V square by R, where R is the resistance, we get an expression for the resistance as V square by P, and resistance is also given as rho into L by area of cross section, means pi R square. So using that, we get an expression for the length of the nichrome heating coil as L is equal to V square into pi into R square divided by P power multiplied by rho, resistivity. So plugging in all the known values here, for V this is 110 square into 3.14 for pi, then the square of radius, which is 0.250 millimeter or 0.250 into 10 raised to the power minus 3 meter square, and divided by power, which is given as 500 watt, into resistivity 1.00 into 10 raised to the power minus 6. And finally this length of the wire comes out to be equal to 4.75 meter, which is the answer for the first part of this problem. Now in the second part of the problem, this time we have to consider the variation in resistivity. So resistivity at initial temperature 20 degrees Celsius, that was 1.00 into 10 raised to the power minus 6 ohm into meter at T1 is equal to 20 degrees Celsius. So first of all, we have to find resistivity at the temperature, at the higher temperature, operating temperature of this coil, which is 1200 degrees Celsius, for which alpha, temperature coefficient of resistivity for nichrome, that is found to be equal to 0.00004 per degree Celsius. So using an expression for the variation of resistivity with the resistance rho 2 is equal to rho 1 bracket 1 plus alpha delta T. So here it is 10 to the power minus 6 for rho 1 plus 1 in bracket 1 plus alpha 0.0004 and delta T, that is 1200 minus 20. So finally here this resistivity now comes out to be 1.472 into 10 to the power minus 6 ohm into meter. And now we have to find the power dissipated by this heating coil at this much temperature, for which its new resistance will be given by R2 is equal to rho 2 into L by pi R square means this is 1.472 into 10 to the power minus 6 multiplied by length, which we have found in the first part of the problem to be 4.75 meter, divided by 3.14 into 0.250 into 10 to the power minus 3 square. So here it comes out to be equal to 35.6 ohm. Therefore, now power dissipated is P dash is equal to V square by R2, means the square of 110 divided by 35.6. So finally the power dissipated by the heating coil now comes out to be 339.887 watt, or we can say it is rounded off to 340 watt, which is the answer for the second and the last part of this problem here. Thank you.